Hi, this is Dr. Y.S. Rao. Last lecture, we have discussed about the programming examples by using QU board and the visual programming language. We have discussed about the LED program, how LED can be made on and off with a delay. And we also discussed about what do you mean by initialization and what do you mean by every component has attributes and how you can change the attributes. Before we go to the next component, next output component, let us discuss little more technical details. As you can see, the LED light emitting diode is a two pin component where long lead is positive, short lead is negative. So it has a polarity. Long lead is anode, short lead is cathode. Like if you see, anode is this, cathode is this. So the cathode, that is the negative portion, is supposed to be connected to the ground potential, means negative voltage, and the anode, which is long lead, which is supposed to be connected to the positive potential, means at least some voltage you are supposed to apply. The LED has two states, forward biased and reverse biased. When the LED will be on, when it is forward biased, if you apply a voltage which is not good enough, then it will be in a reverse biased or a off state. So what do you mean by good enough? Good enough means if this light emitting diode to be forward biased, at least above 1.2 volts you are supposed to apply, above at least to the anode, means positive side, because the LED itself will take 1.2 volts as a drop. So above 1.2, it could be 3.3 volts, it could be 5 volts, it could be 50 volts, it could be 100 volts, it could be 1000 volts. Anything above 1.2 volts, LED will be on, forward biased. However, there is a problem here. One is we are talking about the voltage, how much voltage you should apply to make it forward biased. But then the other important point is the current. The amount of current flowing through this LED, that will decide the intensity of the light emitting diode, because finally the current is converted into light, photons. Now, in general, most of the LEDs, I'm talking about 3 mm, 5 mm LEDs, they have ability to pass only 10 milliamperes of current. Okay, that's all for maximum brightness. If you want to reduce the brightness, then reduce the current, right? Below 10 milliamperes, make 5 milliamperes, 2 milliamperes. But voltage has to be above 1.2 volts. Then only it will be forward biased. It will come to the on state. Okay. Now, how to control the current? Because current is always controlled by a resistor, right? This resistor we have to connect in series to the LED so that this will oppose the flow of current. So if you apply a voltage here, right, and other side means positive side here, negative side is connected here. Let's say if you take a battery, then in series, since there is a resistor, this fellow will oppose the flow of current. Okay, now how much amount of current? The current depends on the value of the resistor, this resistor. So now you need to devise that I want 10 milliamperes of current. My voltage drop across the LED is 1.2 volts. Then find out what should be the resistor value if my applied voltage is 5 volts. So calculate, use Ohm's law. If you have applied a voltage of 5 volts, we are assuming that our entire board, right? Because we are operating through USB. So USB of the computers or any generally supplies will give you 5 volts and maximum current is 500 milliamperes of current. Okay, so we are expecting even our CPU, that's this fellow, the black one, 40 pin IC, and LCD, every single component is working on 5 volts. If you apply more than 5 volts, they are going to be damaged. Okay, including your motors. Now, if 5 volts is applied, voltage drop is 1.2 volts. 5 volts minus 1.2 volts, right? That is 3.8 volts divided by R, some R value is equal to 10 milliamperes of current. Now you have two variables, one unknown variable using Ohm's law. Find out what is the R. So that is the R, let's say 220 ohms, 330 ohms, something, some around like that, is the one you have to connect it in series. If by any chance, if LED is connected to 10 volts, 20 volts, 50 volts, 100 volts, what is that it is changing? Voltage drop remains same, right? Current you have to limit to 10 milliamperes. So only thing you have to change is the R. So R will be keep on increasing if you keep on applying more voltages. So LED never be damaged because of the voltage. You can apply, for example, if you see the Deepavali time, the LEDs are connected to 230 volts. Even your spike guard, right? The spike guard also LEDs are connected to 230 volts. So don't think that there is a step down transformer and converted to 5 volts. Nothing like that. They are having potential of 230 volts AC. In between, they choose a appropriate resistor so that the current is limited. Now let us discuss about how these LEDs are connected to the CPU. This is your CPU, your computational unit, where the programs are downloaded from Atmel company, Atmega 16. This fellow is having total number of pins are 40 pins are there, this fellow, 20 left side, 20 right side. What are the name of the pins? You can see it is given here, like say PA0, PA1, PA2, PA3, PA4, PA5, PA6, PB0, PB, like that. You can see A, B, C, D. Each is having 8 pins. So 8 into 4, 32. So 32 pins if you are having means, like for example 32 LEDs you can connect, right? 32 sensors you can connect, 32 some other interfaces you can connect. That is the purpose of why pins are provided. More pins are provided because independently you can connect, right? Some of the sensors, some of the output devices. So for interfacing purpose, connecting purpose, you require pins, individual pins, because individual pins are individually programmable. So this CPU is having three LEDs, LED1, LED2, LED3 on the board here in this position, where where it is connected, you can see PC5, PC6, PC7. So you can see these are the pins. PC5 means pin number 27, PC6 pin number 28, PC7 29. So if you generally the ICs is left top is pin number 1. So 1 to 20 again, then right side 21 to 40. So these are connected to 27, 28, 29. These three LEDs connected here with the help of a series resistor. Okay, that is the meaning of what do you mean by interfacing. Then rest of the thing is a program. Whenever you say LED on, then on this pin 5 volts is applied so that LED will be forward biased. If you want to switch it off, on this pin 0 volt is applied. So when you say LED off, so what do you mean by LED off? The CPU will send 0 volts here. so that LED will be off. So LED on or LED off is nothing but applying either 5 volts or 0 volts, so that you want to make LED forward biased or LED reverse biased. It's in your hand through program. That is the meaning of interfacing, means connecting to a specific pin of the CPU. These pins are called IO pins. IO means input output pins. Or we also, and these PA, PB, PBC, PD are called ports. So how many ports are there? Four ports are there. The name of the ports are port A, port B, port C, port D. And every port is having how many lines? 8 lines. What are the name of the IO lines? Every port. Port A IO lines are called PA0, PA1, PA2, PA3, PA4, PA5, PA6, PA7. Similarly, port B, PB0 to PB7. Port C, PC0 to PC7. Port D, PD0 to PD7. So that's the nomenclature. Though we are not directly mentioning in the program, because we are using visual programming language. So there it's a simple blocks which are simply we are saying LED1 on, LED1 off, but in reality they are connected on these pins. So this port, this pin is actually either 5 volts or 0 volts is applied, and this entire CPU, right, this fellow is operating on 7.3728 megahertz. Means any digital device, the speed, the operating speed means the instructions which are executed, right, number of uh, instructions per second is decided by this crystal, right, clock, because this is a digital one. So digital systems are all working based on the clock, means either on the rise time of the clock or on the fall time of the clock or on the active high state or active low state. Somewhere one clock means one activity takes place. I'm not saying one clock is equivalent to one instruction. It's very rarely possible. Maybe two clocks, three clocks, five clocks per instruction. That depends on the type of architecture of the CPU or the technology which you are using. All right, so that is about the LED which we have discussed. In this session, let us discuss about another output component called buzzer. As you can see, it's not a speaker we are talking, it's a buzzer. Buzzer means it's a piezoelectric buzzer which is having a ability to convert the applied potential into sound only two state, either on or off. There is no intermediate control. In speaker what happens, the amplitude of the signal you can change, then accordingly it is converting into audio signal. But however, in a piezoelectric buzzer, it has only two states, either buzzer is on or buzzer is off. That means either sound is there, sound is not there. It won't change the amplitude of the signal. So you cannot change the amplitude modulation, you cannot do that. So it is a digital buzzer. So the it has a polarity, negative you connect it to ground as you can see here, and positive we are connected again to the PA7. PA7 means, now you see there is PA7, pin number 33 of the microcontroller is connected to the buzzer. Okay, but anyhow we are not directly related technical details. What we see is that the moment if you select this buzzer component, then in your attributes window, it will give you three offers to you. Do you want to make on? Do you want to make off? Or do you want to make toggle? Toggle means opposite to the previous state. So if you say on, then what it will do? This pin, PA7 pin, it will apply 5 volts. 5 volts means again the same thing, that whatever is the potential you will apply, that will is due to potential difference, that potential is converted into difference, current will start flowing, and that current is converted into some audio sound. If you say off, then 0 volts is applied, no current is flowing, because in both the places the potential difference is same. So if there is no potential difference, no current will flow. So naturally, uh, there is no energy conversion. So in terms of programming, let's look at the program. In the program, yeah, you can write as many programs as you want. One is, let's say you have selected a buzzer on, then you say delay, buzzer off, delay. So between start and end, you have chosen four components. So when you say on, then like I said, you have selected on attribute. When you say off, that means you have selected off attribute. Then in between, there is a delay. So that means it's like a square wave. 1 second on, 1 second off. This buzzer will be. All right, so let's see the